let's go twice again. Okay, here we go, guys. We left off yesterday, we were doing some of these hard examples where they didn't give us clues and we had to find or figure out what possible zeros to start with at the beginning. And then start testing them, and as soon as we found one, we were able to break it down and then go ahead and either factor or find the zeros, etc. But before we went too much further, I wanted you guys to get down just this hint. It's a hint, it's a clue, it's a property about complex zeros. So if there are ever complex zeros, remember we talked about yesterday, every polynomial has n zeros, but you won't always see them on the graph because they're not all necessarily real. Some might be real, some might be complex. They all might be complex. There might not be any real, depending on the function. Bless you. But if there is a complex zero, there's never going to be just one. If there is a complex zero, there's never going to be just one. They always come in pairs. They always come in twos. And these would be what the zeros are. So one example is that the zeros could be a plus bi and a minus bi. But another example that the zeros might just be like 0 plus or minus bi. Those would, or that would be what the zeros are. If they were written as factors though, remember the difference between zeros and factors? Zeros are the x equals a plus bi, x equals a minus bi. Or x equals positive bi, x equals negative bi. The factors would be x minus bi and x plus bi. If we find the zeros, we can make factors, or if we find the factors, we can make zeros. For this top one, it would look a little bit funnier sounding. The factors of this one would be x minus a plus bi, which you could distribute. And then x, not plus, I apologize, minus a minus bi. It's rare that you see one quite as complicated as the one up above on the very top. Usually they're a little bit simpler like the one down below, but just in case you do see one, or it does come up, I want you to be able to see not only the zeros, but also the factors. Not only what they would look like as zeros, but also what they would look like as factors. Okay, so long story short, complex zeros always occur in pairs. That was the hint, that was the clue. That's what this page is all about. And the reason why, or one reason why, I had to tell you guys that is because of the next page. I'm going to go ahead and dual page it just for a second, so that you guys can see the example that's coming and write it down. A few people are still taking notes. We saw this one at the very end of yesterday. I'm not sure if your class got to look at it very long. 3 and 5 got to look at it a bit longer. My question to you is, where's our polynomial? This whole chapter is polynomials and rationals, but that's not until section 2.6. This whole chapter is polynomials. Where is our polynomial? Not there. We're supposed to find it. They gave us the clues about it. But does anybody see something that doesn't quite add up in the clues that they gave us? Degree of 4, real coefficients, zeros of -1, -1, and 3i.
There's no
Yeah, there's supposed to be 4 zeros, and some of you looking at this clue says, wait a minute, if there's a 3i, there must be a positive and a negative 3i. Why didn't they tell us all 4? Because they're like, you should be able to figure out the last one on your own. Because if there is a positive, there must be a negative. If there's a plus, there must be a minus for imaginary zeros or complex zeros. Now, here's the struggle. Just because we filled in the 0 doesn't mean we found the polynomial. But how can we build a polynomial? Let's go from the zeros to their factors. So if the 0 is -1, what would the factor be that got that -1? X plus 1. Well, and if there's another -1, that means there must have been another x plus 1, right? Okay, and what would have gotten the 3i? X minus 3i. And what would have gotten the negative 3i? Well, that looks a lot closer to a polynomial. That's a factored polynomial. Now they want the entire polynomial, meaning the 4th degree, 3rd degree, 2nd degree, 1st degree. They want it all written out. So, struggle. How are we going to go from factors to a polynomial?
Foiling.
Yeah. So basic, it's kind of hard. Now, we do kind of have to, Chris said something about let's FOIL in groups. I like that idea. We have 4 different factors that we have to multiply. So why don't we multiply the first 2 and then the last 2? And then we'll put the 2 together. So, you guys, let me give you, what, 20 seconds? FOIL the first 2. Just what's x plus 1 times x plus 1? You would just do this one. Okay, Chris already has something. X squared.
X squared plus x.
Okay.
Plus x plus 1.
Which combines to be?
X squared plus 2x plus 1.
Okay, now, this does need to be multiplied by the next guy, but we got half of it. We got the first 2 FOILed together. X squared plus x plus 1. Now let's go ahead and FOIL the next 2. This one's going to be a little bit weirder. We can still do it.
X squared.
Okay, now here's what gets a little weird. Now you have 3i times x. Well, you just have to write it. Yeah. Now technically, I was doing outer next. This is going to be a positive 3ix, but yeah. You are going to also have inner a negative 3ix. I know it looks weird, but it's right. It's 3i times x. And then what's the last one going to be? Good. And what happens to our positive 3ix, negative 3ix? Can I do anything with the I squared? Yeah, there you go. So it's going to be x squared minus 9 times a negative 1. What's that going to do? Plus 9. Yeah, buddy, we're right there. We're right there. What's the last thing we're going to have to do? How do you multiply a trinomial by a binomial? You distribute. So we're going to take this x squared and distribute it into both the others. So what's x squared times x squared? And what's x squared times 9? Okay, so far it's taken the x squared and I've taken it to both terms in the other. Now it's time for the 2x. So then 2x times x squared is going to be? And 2x times 9? Now we're not done. FOILing only makes us do the first and then the second, but with this one we have 1, 2, 3 terms, so therefore it's time for the 1. So the 1 to the x squared, and then the 1 to the 9. Okay, how do we combine? Mm-hmm. So I think there's only 1x to the 4th, right? We only have 1 term with x cubed. We do have a couple with x squared. We have 9x squared and 1x squared, which would be 10x. Got it. We have 1 with just an x. 1 with just a constant. I think I got everybody. It's not going to happen very often, but they could give you clues and make you build your own polynomial as opposed to taking the polynomial and solving it this direction. They made you go backwards. Does that kind of make sense?
Yeah.
Okay. Now this could get a little bit harder. I'll come back to that in a second. It could get a little bit harder. This one gives us a clue, but it's not just a positive 3i, it's a 1 plus. But before we do that example, let's just do a quick recap of all of section 2.5. Quick recap of all of section 2.5. If they give you a polynomial, you don't necessarily need to write down the goal. This is just how we accomplish the goal, but if you want to write it down, you can. The goal of 2.5, what we set out to do, and hopefully what we kind of accomplished, is to take a polynomial and to factor him out. And factor him out means to write him as a product of linear and or quadratic factors with real coefficients. And then if they want us to keep going, then we can find a complex of the imaginary if we need to. But to be able to factor any polynomial that has nice factors as a product of those factors. So a quick recap from yesterday. my wording, but it kind of goes along with what the book said as well. We had 2 steps yesterday, we basically had 2 steps today. Step 1 is just to identify all the possible, and hopefully we know more of what this means after yesterday. And then we need to test those possible zeros using different strategies, and hopefully you've seen sometimes synthetic is the best way to go. Sometimes synthetic is the best way to go. Sometimes plugging in and simplifying might be faster, looking for zeros here instead of looking for zeros in the remainder of there. There are other tools and other tests, and I will show them to you quickly today, but I'm not going to have you write them down. I'm going to say, hey, they're there. And I think I gave maybe 1 or 2 homework problems about the tests. So I'm going to say, go look in the section and see if you can figure out what the test says. But these other tools, I'm not going to make you memorize them. I'm not going to make you use them. They just could shorten how long a problem takes if you got a really good understanding of them, just to help you narrow down. Now, there are some problems in homework, though, that to help you narrow down, actually, the homework, I forget if it was 1 section or 2, but it says something like use your graphing calculator. What does that mean? Well, yeah, so, but they give you a polynomial. I'm guessing we're putting it in y equals, right? I'm guessing we're graphing it, right? And zeros or solutions, aren't they the same thing as the x-intercepts? Okay. So when they say use the calculator to narrow down the possible zeros, can we do that on the next problem real quick? Okay? We're going to follow those directions because I know the homework shows that. Just to show you what they're trying to say. They're just basically trying to say we know that there are tons and tons of possible zeros. It's trying to say we know there are tons and tons of possible zeros. So we're not going to make you, kind of like I'm not going to make you, memorize these extra tests that might help you narrow it all down. We're going to let you just take a quick little timeout, phone a friend, aka get your calculator, graph it, and then you have an idea of which zeros you should probably choose. You don't even have to use the zero feature. I want you guys to go ahead, name your calculator, put this function. And I want you to graph it, and I want you just to trace it real fast to the first zero that you see. Just try to get me an approximate of the first zero that you see when you graph this function. If you want to use the zero feature, I guess you can. If not, just trace. For those of us that are just waiting, we're going to go ahead and get it down. And we're going to write, if we don't have our calculators, for instance, we're going to write all the different zeros we would have had to have tested. Oh, the leading coefficient is just 1, so that's kind of boring. So all the different ones we would have had to have tested if we didn't use the calculator to narrow down. Let's see. 1 goes in 60 times, 2 goes in 30 times, 3 goes in 20 times, 4 goes in 15 times, 5 goes in 12 times, 6 goes in 10 times, 7, 8, 10, 12, 15, 20, 30. Whew! Look at that list of possible zeros. That could be pretty daunting. That could be pretty daunting. However, you guys graphing and trying to trace, do you see any x-intercepts at all? Okay, cool. Did someone trace and just try to get really close? What's 1 approximately? Wait, what do you see? 3. 3-ish? Cool. 3. So I'm going to go ahead and plug in 3. And I think she actually found it and said, no, I mean 3, like literally 3. Yeah. Okay, cool. From the calculator, sweet, we know it's 3. So that was our clue. That was our hint. It's like the one I gave you on the bonus, or it's like the one that the book gave you in section 2.3. You can use your calculator to find one and say, hey, let's go. And when we plug in, hopefully the calculator was right. What do you guys think? Was the calculator right?
Yes.
Yes. So, you guys know what those directions mean. This is due on Monday, fully attentive, but real quick, when you see something called Descartes' rule of signs, or upper and lower bound rules, remember those are those tests that I'm not making you memorize, or even know for the test itself. So just go ahead and use your book, see if you can figure it out. The 2 homework problems that I told you to try it on. Get out of your kids, I'll see you later. Happy Friday. Wait till you get through a quiz.
Yeah, I wrote mine.
On the site. and you go to helpful links, and then there's the Precalc textbook. And that's where you can find it. Email me. Which honors left? The test case.